Good evening, my viewer. This evening we're going to cover a broad topic. It will take us about 3 weeks to cover, and an estimate of about 20 videos of about 5 minutes. Our first biggest topic is trigonometry, and under that we shall look at the general angle and Pythagrous theorem. Under the general angle and Pythagrous theorem, we have another small one called the general angle. As you realize, in trigonometry we shall be building concepts, and it's ideal, it's really good that you understand the first concepts such that as we build on, you will not get lost. So in our first expression, we are having given the diagram. Okay, so that's our diagram. We are having our y-axis, and then of course our x-axis, and then of course the original point or the point of reference, point O. So we are saying all angles that are measured on OX in the clockwise sense are negative, and all angles measured in the anti-clockwise sense on the OX are positive. And that's our NB we are writing down there. And so as we shall be measuring, take note of that in any case, as you measure the angles going to the clockwise sense, that is the direction to which the clock ticks, all those angles are going to be negative, be it acute, be it any other angle, but most cases we shall be basing on acute angles. You'll observe that as we continue. And the angles that we measure in the anti-clockwise sense, that is in the opposite direction to that to which the clock is ticking, are always going to be positive angles. So take note of that NB as we proceed. So given another diagram of which it is a circle of radius r making a point P, x, y. So if it makes a point P, x, y, it means it has a height of y and a base of x, and the radius of course is r. And if it makes an acute angle of theta with the OX, so we have said from SOHCAHTOA, sine theta is equals to opposite over hypotenuse, and our opposite is the height y, and the hypotenuse is of course the radius r. And we are also saying that cos theta still from SOHCAHTOA is equal to adjacent over hypotenuse, and our adjacent in this case is the base x, and of course the hypotenuse remains r. How do we identify the adjacent and opposite? That's O-level work. I will refer to more videos that will be coming in O-level such that you can understand the opposite and hypotenuse. And of course tan is equals to opposite over adjacent, and therefore tan theta is equal to y over x. Also, tan theta can be expressed in terms of sine theta and cos theta. We have said sine theta is equal to y over r, and we are saying cos theta is equals to x over r. Now once you divide sine theta and cos theta, you'll end up with y over x, and we have already seen that y over x is what we are calling tan theta, and therefore tan theta can be also expressed as sine theta over cos theta. Now in A level we are going to introduce more concepts, like for example the cosec theta, which is equals to 1 over sine theta, or the reciprocal of sine theta. sec theta, which is 1 over cos theta, or the reciprocal of cos theta, and cot theta, which is equals to 1 over tan theta, or the reciprocal of tan theta. Most people confuse cosec and sec. Please take note that co does not mean cos, but it implies the inverse of sine, and sec of course takes on cos. And so we are going to illustrate a little more. We are going to now use the following diagram to identify the quadrants in which these angles exist and in which signs do they exist. So of course we know very many ways of cramming this. All short teachers complain, all science teachers cram, or if you are biblical you can say acts. So in where there is A, all are positive, C, cos is positive, T, tan is positive, and S, sine is positive. So wherever there is sine positive, it means the others are negative, that is tan theta and cos theta. And wherever there is tan positive, same thing applies. However, for all, it means all of them are positive, and this carries on even with the cosec, which is the reciprocal of sine, the sec, which is the reciprocal of cos, and the tan, which is and the cotangent, which is the reciprocal of tan. By the way, cosec is the same as cosecant, cot is the same as cotangent. Those are just their short forms. So our first example says express the following in trigonometrical ratios of acute angles, and first we are beginning with sine of 150. Of course you know that acute angles are angles that measure from 0 to 90. So how do we find the acute angle of 150? We get the closest axis, and not any axis but the x-axis. So we draw our angle 150 beginning from the OX as usual, measuring the positive direction, which is anti-clockwise, and then the remainder of that angle to the x-axis, to the 180 axis of gives us the acute angle, which is 30. However, we know that in that particular quadrant, sine is positive. Therefore, the sine of 150 is the positive sine of 30. Always remember to include that sign, that positive sign, because it is really important. Our B says cos of 150. I'll ask you to try out cos of 150 before I do it. And so once I do it, my answer is going to be, of course, I draw my axis again and then measure off 150 and then get the acute angle of 150, which is subtracted from the nearest x-axis. Are we okay? So our acute angle is still 30 because it is the same angle 150, and therefore we shall now obtain what is the sign of cos in that quadrant. We know that from acts in that particular quadrant only sign is positive, therefore cos is negative, and therefore cos of 150 is the same as negative cos of 30. I would ask that you try this on a calculator and see whether you obtain the same answers. I'm sure if you use your calculator rightly, you'll get the same answer. And so I'll leave a few exercises for you to try out, but please take note of the sine and the acute angle. They are going to be a basis in very many aspects under this. Try out for tan 150, during your free time, and I expect you to get the answer. So my exercise here is I'll post them down there, and I also post answers aside such that you can keep referring to the correct answers. Okay, thank you.